Now it's recording. Okay, so what is the strategy for solving this equation? Well, you try to find a common base. You try to find the common base. Common base. And you try to express both sides using the common base. In this case, it's obvious that the common base is 2, because 8 is 2 to the third power. 2 times 2 times 2, ¿no? Entonces you write 2 raised to the 3 minus x is equal a, pero I know que a is 2 to the third power. Okay, entonces in this moment, if we have two exponential functions and the base is the same, the conclusion is that the exponent is the same. So magically, you convert one exponential equation and one Isar equation, in this case linear equation. Es obvio que the answer is 0, no? Because 3 minus 3 is equal x, 3 minus 3 is 0. The answer is 0. Any question? Okay, the challenge is, no. Okay, the challenge is obviously try to find the common base in each problem. I have a lot of problems. Suppose 5 raised to the 2x plus 1, this is exponent, equal 25. And so for x. My question is, what is the common base in this case? 5. Very well, because 25, I know is 5 squared. Therefore, immediately 2x plus 1 is equal to. You convert to elementary linear equation and you solve in this elementary linear equation. 2x is equal to minus 1, que es 1, divided by 2, x 1/2. Any question? Example 3. Suppose 20. Can we move it to see? Okay, of course. Okay. Like that. It's okay? Okay. Suppose, Caroline, the example 3 is 27 raised to the 4x. This is the exponent part, equal 9 x to raised to the x plus 2. In this case, what do you think is the common base? In this case, what do you suppose is the common base? A3. You're right. You're right. A3. A3 because I know at one corner of the piece of paper I write 27 is 3 cubic. Can you keep the... Okay. Like that? Okay. I know that 27 is 3 to the cubic power. 3 times 3 times 3 times 3. And 9 is 3 squared. So 3 times 3. So you replace, not 27 anymore, it's 3 cubic raised to the 4x. Okay, this is exponent, it's another level of the exponent. 3 squared raised to the x plus 2. Okay, so in this case, you apply the property that when you have different level of the exponent, you multiply the exponent. Suppose you have x to the second to the third. This is equivalent to say x to the 6. Welcome from 6, multiplication 2 times 3. This is the one rule of the exponent. So we have 3 raised to the 12x, so 3 times 4 is equal 2 times be careful because 2 times the whole expression, the entire expression, x plus 2, something like that. Now we have 2 exponential. The base is the same, so I intentionally put the base the same. Therefore, immediately the exponent is the same. So you convert the exponential equation and another equation easier is linear. You apply distributive property. You try to solve for x. 12x minus 2x equal 4. Is it 10? Equal 4 divided by 10. And finally, why now? You reduce the lowest term because it's divisible by 2 is even number 2/5. That's the final answer. Easy or complicated? And the test, you can see in the test 4 at least 2 questions similar to this, in which you manipulate both sides of the exponential equation and express it using common base. Okay, example 4 is a little bit confusing. Is square root 3 raised to the x plus 4 is equal 3 to the x. My question again, what is the common base? This is the classical question. What is a common base? And also the complementary question is how you express in both sides using the common base, no? It's obvious que 3, no? It's obvious que 3 because square root 3 in my mind working like a 3 raised to the half. Remember the fraction exponent. When you have fraction exponent, when you have any root, suppose you have, I don't know, suppose you have a cubic root of 3 to the second power. This is equivalent to write 3 2/3. So this 2 is this 2, and this 3 is the index of this. In this case, in our particular case, is square root default. We have a 2. It's the index of the square root. And when the people omit the 2 is because default you suppose it's a square root. And when the people omit the exponent here, it's because it's 1, so it's 1/2. So you replace 3 to the 1/2, you replace for radical 3 raised to the x plus 4 equal 3 raised to the x. One more time, you apply the rule of the exponent, multiplication different level of the exponent. This is 3 multiplication 1/2 times x plus 4. The parenthesis is super important, guys, because you multiply this number times this entire expression. And the correct way to indicate this idea is using the parenthesis, no? Because you omit the parenthesis, I suppose, que 1/2 multiply only x. This is wrong. Equal 3 to the x. Okay, again, the same situation. We have 2 exponential, and the base is the same. Therefore, the exponent is the same, and you copy separately. 1/2 x plus 4 equal x. Okay, now there are many ways to do this. I like so much multiplication, the entire equation by 2, because I want to eliminate the fraction. It's one possibility, multiplication, the entire equation by 2. Ya I know that 2 times 1/2 is 1, so it stay only x plus 4 equal to x. Because 2 times x is 2x, and 2 times this is 1. So 1/2 times 2 is just 1, and 1 is invisible. Now, finally, 4 is equal to x minus x. I move this x to the right-hand side. Entonces 4 equal to x minus x is x. Wow, it's the answer. X equal 4 is the answer. And important to say something, no? In the exponential equation is nice because the exponential equation, you don't need to verification. So you suppose that you are doing well, then you don't need to check in the solution into the original because the exponential function, you know, okay, the domain is all real number. So the exponential function is nice function. Remember, another function is not nice, then you need to check it. But in this case, no. Okay, one more example. Example 5. 2 raised to the 1 minus 2x equal 8 raised to the x plus 1. So I ask by myself, what is the common base in that case? Tell me. What is the common base? And between 2 and 8. Hey, hello. What is the common base? 4. No 4. 4 no, because 2 we can express it using 4 base. You can, pero no. Okay, no. Okay, es 2. Es 2 porque 2 es 2. And you say, bueno, A es 4 and 2. Pero okay, no, pero entonces we have 2 bases. ¿Es 4 o es 2 o es 2 o es 4? No, es 2. Because 2 es 2 and A is 2 to the cubic power. It's 8. So no 4, forget about 4, it's incorrect. The 2, 1 minus 2x is equal to 2 to the cubic power raised to the x plus 1. Okay, now again multiplication the different level of the exponent is 2 times 3 times parenthesis x plus 1. Okay, now I am ready. We have two exponential. The base is the same, therefore the exponent should be the same. Should be, no, must be the same. So 1 minus 2x is equal to 3 times x plus 1. The rest is pretty easy. It's intermediate algebra. Distribute the property. 1 minus 2x is equal to 3x plus 3. I suppose that 1 stay here, minus 3 I bring to the left, 3x stay here, and 2x I bring to the right. Entonces it's negative 2 is equal to 5x divided by 5 both sides. The answer is negative 2/5. The answer should be positive, should be negative, depending. Remember, the domain of the exponential function is all real numbers, so you can consider exponent negative or exponent positive or exponent 0. There are no problems, there are no restrictions. Any question? Do you understand the idea? Do you understand very well que es 2, no 8, no 4? Sure? Okay, I need help in number 6. Que look like horrible. Okay, we have 2/3 fraction. Okay, and root raised to the x power is equal 9/4. Okay. Entonces, what is the common base in that case? Well. I can see, for example, I know que 9 is 3 to the second power, no? I try to stay relationship between this and this. I don't care que it's in the top or the bottom. And 4 is 2 to the second power. So you replace this. Look. This is 3 to the second power over 2 to the second power. Okay, so I bring down 2/3 raised to the x power. And why not? You can put together like a 3/2 raised to the second power, que it's the same, right? Now when you know, a over b raised to the 4th power. This is equal to a to the 4th power divided by b to the 4th power. This is another property. of this. Oh, but what's the problem? The problem is in the left hand side we have 2/3, 2 over 3. In the right hand side we have 3 over 2. So what should I do? What should I do? What should I do? To solve that problem? What is the relationship between 2/3 and 3 over 2? Es recíproca, ¿no? Es recíproca. And reciproca is, you know, negative exponent. So you know that, for example, 3/2 raised to the negative 1 is 2/3. Oh, likewise, 2/3 raised to the negative 1 is 3/2. Es recíproca. The relationship es que 2/3 es el reciprocal of 3 over 2. Entonces, either way, I don't know. Suppose que you keep it like that, this. I flip it that 2/3, but I know que you include a negative 1. So 3/2 replace 3/2 full. Raised to the second power, no? Okay, these two stay here. Actually is 2/3 multiplication of the exponent is negative 2. Wow, I finished. Therefore, we have two exponential. The base now is the same. The exponent is the same. Final answer. Do you see that or no? Do you understand this? Hey, answer me.
Yeah,
Guys?
yes.
Uh-huh. Okay. One more. But I need help. Because it's easy, no? It's easy or not? The student normally, when they teach that part, like this. Because it's easy, relatively easy. 32 raised to the x plus 2. Can you keep up? Okay. Like that is okay? X plus 2. You need the 6, only the 6. Okay. So 32 raised to the x plus 2 equal 16 raised to the 2 minus x. Entonces my question is, what is the common base that I need to use in this problem? What is the common base? What is the common base que stay relationship between 32 and 16? 8. I suppose que no, because a to the first power is 8. Y a to the second power is 64. Remember, this is exponent, no multiplication. Entonces, maybe 8 times 2, maybe in your mind, 4. Okay, 4. 4, no, Caroline, look. 4 to the 1 power is 4, correct. 4 to the second power is 16. Okay, good, because it's 16. But 4 to the third power is 64. So we never get 32 using base 4. No. No 8, no 4. I suppose que es 2. Porque 2 to the 1 power es 2. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. And 2 to the fifth power is 32. And we're using basically this relationship. Okay? Entonces is to the fifth power, replace 32 to the fifth power, raised to the x plus 2, is equal to the fourth power, que is equivalent to 16 raised to the 2 minus x. Okay, now multiplication. Multiplication, the exponent is 2 raised to the 5 multiplication. Don't forget the parentheses. It's important, this parenthesis. 2 for 2 minus x. Okay, now this is a super important moment. You have two exponential function. the same base. I create this intentionally. Now the exponent is the same. So you copy down 5 x plus 2 equal 4 to minus x. This is a linear equation, easy to solve. 5x plus 10 equal 8 minus 4x. Okay, 5x stay here, plus 4x I bring to the left. A stay minus 10. Okay, this is the manipulation. This is 9, and this is negative 2. Divided by 9, both sides. X is equal minus 2 over 9. Final answer. I'm checking in my paper. Yes, perfect. Good, very good. Do you understand very well or no? Exponential equation. One more, huh? Let's do one more. Let's do one more. Let's do one more. And let me see if I bring on. Yes. Here I have 2 extra credit for the brilliant student who need to get 10 extra points. See, you are doing the extra credit. Okay. Suppose the last one without extra credit. Okay, number 8. Example 8. Well, example 8 is, wow, it's a cubic root of 5 raised to the minus x. Wow, negative exponent, cubic root, complicated, confusing. It's equal 1 over 5, okay, raised to the x plus 2. Okay, this is no extra credit. I want to solve this. Extra credit is after this. Well, in your opinion, what is the common base? In your opinion, what is the common base? 5. Es obvio que 5. Es obvio que 5 because cubic root of 5 is 5 raised to the 1/3. Where I come from this 1 is the power. Where I come from this 3 is the index of the root. And 1 over 5 is the reciprocal of 5. 5 raised to the negative 1. Remember, negative 1 exponent is reciprocal. Replace 5 raised to the 1/3 raised to the negative x is equal 5 raised to the negative 1 raised to the x plus 2. Now multiplication is 5 minus 1/3 x is equal 5 raised to the negative 1 times x plus 2. Now we have in that moment 2 exponential equation, and this exponential equation contain the same base. Now the exponent is the same. So it's negative 1/3 x is equal minus x plus 2. You multiply the whole thing by negative 1, or no, much better, by negative 3. You multiply by negative 3 whole thing, this entire equation. You are doing 2 important things. Number 1, delete the fraction, clear the fraction, and number 2, clear the negative sign. Entonces, actually it's x, only x, because when you multiply negative 3 times negative is positive, and 3 times 1/3 is 1, and 1 is infinity. And negative is positive again, but it's 3 times. Entonces, more. Apply distributive property. Apply distributive property. Now finally I move minus, combine, and finally divided by negative 2, no? The answer is negative 3. Let me check it in my paper. Yes, that's the answer. Is the answer? Yes, it's the answer. Okay. Well, the extra credit, no, not yet. Why not? Because you need to know something before the extra credit. Okay, any questions so far, guys? It's easy or it's okay. Entonces, I recommend, bueno, in the review packet you can see. In the review packet you can see what is the typical question in the test, no? However, I guarantee you that we have at least 2 questions about this problem, exponential equation. But this is exponential equation, okay, you can manipulate both sides and convert to linear equation. But sometimes it's impossible doing that. So we have, this is the regular exponential equation that we studied so far. But we have a special exponential equation that we study now. Special exponential equation. Entonces, for example, one typical example of the special exponential equation is 2 to the x equal 3. Wow, we cannot solve it in that way, in the regular way, because we never can express it 3 as a power of 2. Suppose you have 2 to the x equal 4. Yeah, we can, because 4 is 2 to the second power. And therefore, x is 2, end the story. But in this case, no. But entonces, you can solve it, bro? Yes, we can. We can solve it. However, to solving this equation, I am put inside the box. This is pending because we need to study new things, new tools to manipulate this equation. Yeah, this is logarithmic functions. This is a chapter, important chapter, guys. Okay, we study 2 new functions: the logarithmic functions, the exponential function, and the logarithmic function. Okay, logarithmic function is a new function that we study now. And this function, I suppose, can help me to solve this equation. Here's another application that you can see throughout the chapter. Okay, logarithmic function. What is the definition? What is the definition of the logarithm? Well, logarithmic function is the inverse function of exponential function. This is the definition. So let me recall quickly. Recall exponential. Exponential is a function like that. F of x equal a to the x power. A is the base. Remember that the base have restriction. The base is always positive number, never negative, impossible. So this expression, -2 raised to the x power, this is impossible. Okay, it's positive, and no 0 and no 1, because it's a trivial example. Okay, this is the idea for the exponential, and we're working using exponential equation, no? Okay, now, suppose I want to find a new function that is logarithmic. And logarithm is the inverse. And remember the idea for the inverse. What is the equation for the inverse? Well, the equation is, look. You replace immediately f of x for y. This is also exponential. Now you interchange x and y. This is the most important idea for finding the equation for any inverse function. So x is equal a to the y power. Wow. And this is logarithmic. Well, almost. This is the inverse, yes. This is inverse, but this is implicit. Implicit form. Implicit form is not good. I don't like. I like explicit form. And explicit form is when you isolate the y. Okay? Now it's inverse also, but I need an explicit explicit, it's important. Entonces now I transform a little bit this expression to another expression, and what y is totally isolated. And you create one que the special notation is like a function notation, no? It's f of x, something is a function notation, right? But in this case, the name of this function is logarithmic, log. You put log. Log of what? Of the x. And your specification here is small number can indicate the base. So this a is a small number can indicate the base. And this is the idea. This is the formal definition, no? For the logarithmic function. Okay, but I need to understand much better. I need to understand. So far, everyone follow me? Okay, now interpretation. Interpretation, because I need to understand very well. Interpretation. Okay, in the real life, we have two kinds of statement. Exponential statement and logarithmic statement. It's two different ways to express the same idea. This is the same idea, but in different form. Let me try to explain in detail. Look, suppose that we have 2 to the 5th power equals 32. It's a classical exponential statement. And we have the base, que es 2. We have the exponent, que es 5. And we have the result, que es 32. Okay? And you can change these two logarithmic steps. Of course, yes. Always in both directions. So sometimes, this is the classical idea that we are applied so far. We have one statement that you consider hard, I don't understand very well, and you can change to logarithmic statement or in backward, in opposite direction. So this is, look, log, you put the name of the function, log, look. And you specification a small number que represent the base, que the base is obvious que es 2 in this example. You put a small 2, que es this big 2, and the exponential is this small 2 in the logarithmic, right? And you open the parenthesis because this is look like function notation, and the answer of this logarithm always x exponent. This 5 is the answer, and the number inside the argument of the function is 32. So what is the interpretation? The interpretation is the logarithmic statement always give me information about what exponent, que 5, is necessary to raise 2, que es the base, in order to get 32. So the answer que offer the logarithm is always the exponent. This exponent, you need to raise the base 2, in this example 2, in order to obtain 32. One more example. Suppose 3 to the 4th power equal 81. This is classical, because 3 times 3 times 3 times 3, 3 times 3 is 9, 9 times 9 is 81. Good, this is good. Now you want to change to the logarithmic statement, is you put log. What's the base? Oh, the base is 3 in this example. And the answer is 4, get the exponent. Look, this 4 is that 4. Okay? And the number inside the argument is 81. Do you understand very well this or not? So in general, we have in the exponential statement, we have base. We have exponent. I want to call this guy result. Result of what? Well, result of the exponential statement. When you switch into the logarithmic statement, you put the magic word, and the small number you put here at the base, is this number. And inside the argument, you put the result. Result of what? Of the hypothetical exponential statement equal exponent. That the answer que offer is the exponent. Super? Okay. Let me see if you understand or you don't understand. I bring example and you help me. Okay, today, look, today is a day that we are working without calculator, Everything we are doing by hand today, by hand. However, in the last class, next week, we're using calculator. What kind of calculator? Okay, mandatory calculator. Without calculator, you don't pass this test. Scientific, pero not necessarily super expensive calculator, cheaper. Like, for example, I recommend TI-30. This is Texas Instrument 30X, cheaper, 12 bucks. In Walmart and in Office Max. Okay, everyone bring one next class. Not necessarily this. Another scientific calculator we are familiar. Suppose you have in your hand, you bought before a calculator, scientific, no 2 plus 2. Scientific because in this chapter we need to using logarithmic function and exponential function. Okay. Pero today without calculator. Okay, suppose. Logarithm base 10. I use base 10 because base 10 is easy to understand. In this previous example, I use base 2 and base 3, but I use base 10 to discuss it with you. Of the 100 equal, I have no idea without calculator. I need help. What do you think? No idea, totally lost. Try to guessing. Remember the idea for the logarithm. Es 10. No. 10 no. It's not 10. Okay. What is the idea? The idea is what is the exponent que es necesario to raise 10, que es the base, in order to get 100. Es 2. Very well. Es 2. Okay. Let me try it. Okay. We can use in the common sense. Okay. We can use the common sense. Good. Common sense. Or I want to teach you another way, elegant way to find out by hand. Suppose I have no idea. I put X. Because I have no idea. However, my common sense is not clear to understand the logarithm so far. Entonces, I propose you convert this statement to exponential. Entonces, I recommend you put an arrow like that in the test, and you put conversion to exponential. I understand very well. You put to exponential. Entonces, what is the base? The base is 10. So this small 10, you put like a big 10. Remember, I remember the answer for the logarithm is the exponent. It's exactly I am looking for is equal the result, que is 100. Now I have in that moment in front one exponential equation similar to the exponential equation we are doing before. So 10 raised to the x power is equal 10 squared, because I know that 10 times 10 is 100. Therefore, we have two exponential, the base is the same, the conclusion is x equal to. Do you understand this or not? Clear or confusing? Clear, Sabrina say. Okay, so you help me to the other more complicated example. Look. We continue doing logarithm 10 because it's easy to understand. Of 1000, what do you suppose is the answer? Intuition or conversion to exponential? Intuition or conversion to exponential. So we can use intuition. You put directly the number. Oh, you are doing it that way. Okay? No idea? Totally lost?
The answer is 3.
The answer is 3. The answer is 3 because I realized que 10 to the cubic power is 1000. Wow, it's easy. Entonces it's easy, professor, because si we have 2 zeros, 2. Si we have 3 zeros, 3. Well, no. This situation happened because the base is 10. Si the base is not 10, well, entonces it's different. This is 1 million. What do you think about 1 million? Logarithm base 10 of 1 million. 1 million is 1, 2, 3, 4, 5, 6, 0. 6. The subject is 6. Okay. Entonces, you understand or you don't understand? You understand or you don't understand? No? Clear or confusing? Hey, answer me. Oh, activate the chat. Clear. Okay. Sabrina say it's clear.
Clear, professor.
Uh-huh. And what about logarithm base 10 of 10? What about logarithm base 10 of 10?
1.
A1. Very well. Okay. Entonces I take advantage this moment. When you have logarithm of the any base and the argument of the logarithm is by coincidence is the same number, the answer is always 1. The reason is clear, right? Suppose that you convert to exponential. Well, the base I know is 10, this 10 is this 10. The exponent is 1, it's equal to 10. Excellent. What about, I want to complicate a little bit. Suppose logarithm base 10 of the 0.1. What do you think? What do you think? Wow. I have no idea. Somebody have idea? No? Yes? Well, look like complicated. The intuition doesn't work very well. Therefore, I put x. I convert to exponential. I know that the base is 10. I put a big 10. This big 10, this is small 10. The exponent is exactly I am looking for is equal to 0.1. And 0.1, so you express it like fraction, is 1 over 10. And so you express it as a reciprocal, is 10 raised to the negative 1. Therefore, in that moment, we have 2 exponential. The base is the same. Therefore, the answer is negative 1. Wow. This is a good conclusion. Okay. Now, I don't know. This happened when the number inside the argument is greater than 1. The answer of the logarithm is positive. However, when the number inside this is less than 1, the answer of the logarithm is negative. Look at that, it's negative. What? Who helped me with the logarithm base 10 of the 0.01? Using the common sense now. Using the common sense now. No? No common sense? Entonces let's convert to exponential. I have no idea, but x convert to exponential. Convert to exponential. The base is 10. The exponent, I don't know. And this is 0.01, is 1 over 100 in fraction. And it's 1 over 10 squared. Like a power of 10, is my goal. To find common base, but it's reciprocal. It's 10 to the minus 2. Therefore, the answer is x equal minus 2. Okay, so when the number is smaller, that one, the answer of the logarithm is negative. Okay. One last special important case. Logarithm base 10 of 1. What do you think about this? Big question mark. Logarithm 1. No, no idea. No idea. Nobody. Guessing. No intuition. So we convert to exponential. Again, one more time. The base is 10. The exponent, I have no idea. Equal 1. But I know que 1 is 10 exactly. Es 1, no, 1 es 10. Okay, hello. Look, Ruth, logaritmo es 1. When it's 1, it's 10, the argument. But in this case, the argument is 1. Where's the answer? Okay, I know que 1 is 10 to the 0. Because I need to remember que any number, any number or expression raised to the 0 power is equal 1. Therefore, the answer is 0. Okay, extremely important property. Logarithm of the any base of 1 is 0. Logarithm of the any base of the same number is 1. Do you understand? Do you get the idea? Do you get the idea? Well, so you get the intuitive idea of the logarithm, get a new function that we are studying. I propose you write the most important property for the logarithmic function, no? But remember, the logarithmic function is the inverse function for the exponential. Now, let me try to summarize some property, no? Of the property for the logarithmic function. But before that, I want to switch into Desmos because I want to see in Desmos something interesting. Wait a second. Here, bam. Okay, you switch into Desmos. Let me see. Wow, no. Okay. Okay, I try to share screen. Switching. Okay, there you go. Is it Desmos? Do you see Desmos now? Do you see? Do you see? Yes or no? Okay. I present to you the exponential. This is the exponential we studied last time. Okay, in this case the base is 2. Okay, remember the super universal point 0,1, 1,2, because the base is 2. See, the base is 3, no, it's 1,3. And this is base 2. Now I present to you the graph of the logarithmic. And the logarithm is easy to understand because it's the inverse function. So you interchange x and y. For example, in the exponential, we have the famous point 0,1. And the logarithmic, we have the famous point 1,0. And makes sense because we studied so far that logarithm of 1 is 0. Okay, logarithm of 2 is 1 because the base is 2. I suppose in this curve, the base is 2. This curve represents the logarithmic function. This curve represents the associated exponential. But no, let's focus on the logarithmic function now.
Professor, okay. I don't see anything.
You don't see anything? Okay.
The screen is black.
It's black. Wow. Okay, let me try again one more time. And now? And now? And now, miss?
No, I'm gonna log out to see if it's me. Thank you.
Entonces, it's your issue, it's your problem because Sabrina said que yes, I can see.
Okay,
everyone,
so I'm gonna log out.
It's okay.
Thank you.
No, it's okay. Okay. Entonces, the most important, let's focus in this curve because I want to summarize the most important property. For example, I can see clear, for example, the logarithmic function have positive value when the number is greater than 1 and negative value when the number is less than 1. And 1 is specific as 0. So the range of this function is all real number, positive, cover positive, and cover negative. However, the domain, be careful, the domain is only positive value. No, never we have negative value. O sea, logarithm of negative number is impossible. Negative number is completely out the domain of the logarithmic function. And 0 is also out the domain because logarithm of 0 is undefined. That is a reason that the logarithmic function is asymptotical. We have a vertical asymptote. Look at that. It's the vertical asymptote. Look, vertical asymptote. Vertical asymptote at x equals 0. Do you see this dotted line? Vertical asymptote. Okay, logarithm of 0, guys. Let me switch again to the whiteboard. Whiteboard. Okay, switching. Whiteboard. A ver, let me see. Yeah. Whiteboard. Okay. Do you see whiteboard now, right? Very important to understand the logarithm of the any base of the negative number is undefined. It's totally out of the domain. And logarithm of 0 is also undefined. Thus, regardless of the base. Undefined. Okay, so now let me summarize quickly in the time we have, because not too much, the most important property for the logarithmic function. So property of logarithmic function. Okay. Number one, domain. What is the domain of the logarithmic function? Well, it's from 0 to infinity. So only the positive number, of course, not including 0 and not including negative number. And the range, no, the range is nice. It's all real number. And this makes sense because I suppose that you remember again the exponential function. In the exponential function, domain is a real number and range is a positive value. Entonces you interchange x and y. You interchange domain and range. Look, this guy is this guy and this guy is this guy. It's no surprise because it's the inverse function. Number 3, property. We have x in a set at the famous point 1,0, que es the universal point. The word universal indicates regardless the base of the logarithm that you are working, passing through 1,0. That's universal point. And y in a set we have no. Unfortunately, no. Property number 4. If the base is greater than 1, well, let's see, not today, next class, is the function is increasing. See, the base is in between 0 and 1, is decreasing. And we have two kinds. It's similar to the exponential. We have two kinds of the logarithmic. The classical that we study now. In this case, the base was 2, no? Pero suppose que the base is not 2, it's 1/2. Entonces it's different. I want to study next class. Look like that. Passing through the same point, famous point, but it's like that. This is when the base is decreasing and this is increasing. Okay, number 5. The typical point to do the graph of the logarithmic, it's one question in the test that do the graph of the arbitrary value of the logarithm is the typical point, typical point are 1,0, of course, the universal. Don't forget this, que es important. The base, que the base is a, 1, and the reciprocal of the base, que es 1 over a, que es -1. Okay, suppose hypothetical. Logarithm base 2 of 1 is 0. Logarithm base 2 of 2 is 1. Logarithm base 2 of 1/2 is negative 1. Okay? And don't forget, important, don't forget the vertical asymptote any graph of the logarithm function have at x equals 0. Suppose in the test, I have equation, you put equation like that, case graph this logarithm. Suppose f of x equal logarithm base 3 of x. Okay. Let's do it quickly. I plot the 3 typical points. Okay, the 3 typical points are 1, 0, universal point. And to say take advantage of the typical point is logarithm base 3 of 3 que es 1. Entonces 3,1, 2, 3,1. Remember, this is the x value, this is the y value. Another point here, 3,1. And the reciprocal of the base, que es 1/3, is negative 1. So 1/3, I take this segment and divide by 3 portions. 1, 2, this is 1/3, the first one. And negative 1 here. And we get this point. This point is a point 1/3, comma, negative 1. And we connecting this point by the curve. Okay, you know a little bit, the curve look like that. Okay, this logarithm base 3 of x. And don't forget, important, the vertical asymptote at x equals 0. So we have any graph of the logarithm function. This is important piece of information when you are doing the graph. At x equals 0. Vertical asymptote. End the story, guys. Super. Any question? Okay, so we continue next class doing the logarithm. Don't forget, please, to bring the scientific calculator. Okay? Cheaper. Do you see my face now?
Yes, Professor.
Okay, look at that. This calculator is good. Super good and super non-expensive. I have another super fantastic calculator, no good. It says $150. No. Another possibility is maybe you can find online this case no too expensive. Okay, I recommend this. I recommend. This is available in different color: black color, blue color, pink color for the girl. Because I want to work next class with this calculator or similar. Any question? Bye bye.
Professor, thank you.
My pleasure. Anytime.
Have a good day.
You too.